All right, now we're going to finish solving this inequality. So we already have our boundary points marked. Now, what those boundary points do on our number line is break it up into what we would call, let me try and get this on here so it's kind of in the right place here, and to what we would call like 3 regions of the number line. Okay, so here's region 1, region 2, and region 3. What we want to do is pick a point in each of those regions, pick an x value in each of the regions, and test it in the inequality and see if it would make the inequality true. And then what we know is that if one point in that region satisfies the inequality, then all the points in that region will satisfy the inequality. So we only need to test one point from each region. So what I'm going to do is kind of set up ahead of time which points I'm going to use. I like to use, the smallest numbers possible, or 0 whenever possible. Now we're not going to pick a number that's on the boundary, okay? So we do not pick -3 or 1. We pick numbers that are something outside of those values. So I'm going to show you what I'll do. I'll take that, let's start with -4. So when x equals -4, that's region 1. I'm going to plug in -4 into my inequality. So I'll have 4 times the absolute value of -4 plus 1 minus 2, and I'm trying to decide if that is greater than 6. All right, so I'd have 4 times the absolute value of -3. That's going to be 4 times 3 minus 2, which is going to be 12 minus 2, and that is 10. And 10 is greater than 6. So I know the points in that region will work. We'll come back to that in just a second. Second region, region 2, I picked 0. So I'm going to plug in 0. So 4 times the absolute value of 0 plus 1 minus 2, and I'm trying to see if that is greater than 6. So that's 4 times the absolute value of 1, which is 4 minus 2, and that's 2. And 2 is not greater than 6. So that means that this region does not work. So let's try region 3. Once again, I've already picked ahead of time x equals 2, so I'm going to plug that in. 4 times 2 plus 1 minus 2. I want to see if that's greater than 6. So 4 times the absolute value of 3. That's 4 times 3. And we get 12 minus 2, which is 10. And once again, we see that that works. So here's what I know. I know everything in region 1 and everything in region 3 works. So what I can do is I can say, okay, it's all of these numbers with an open circle here, and then all of these numbers. Okay, and so we can write that with our inequality notation, or interval notation, sorry, as -infinity to -3, and then 1 to infinity. And I think this is how we would like you to write your solutions algebraically, and this is how we would like to show your solutions graphically.